Hello my dear viewers, welcome to KCSE Mathematics Paper 2. I'm Mr. Michael Samuel from Michael Samuel Teacher. You can get me on YouTube by that name, and therefore we are going to start with the section 1 of KCSE Mathematics Paper 2 2023. So question 1, solve the equation 1 plus log into bracket 2x minus 9 is equal to log of 3x plus 5 into bracket minus log 2. So in this case I want you to know the laws of logarithm, then it will help you to tackle this question very well. So we have 1 plus log of 2x minus 9 is equal to log of 3x plus 5 minus log 2. If we consider this equation to be log to base 10, then it simply means that the first part, which is 1, will be log 10. Remember, log of a number base to that number is equal to 1. So if all of them we consider them to be log to base 10, then 1 will be log of 10, then plus log of 2x minus 9 will be equal to log of 3x plus 5 minus log of 2. So from there, using the laws of logarithm, whereby if you have log A plus log B is the same as A times B, and also log A minus log B same will be A over B. Therefore log of A over log of B. So in our case then we shall write this as 10 times 2x minus 9 will be equal to the other one. We have minus, so that will lead it to division. So we shall have 3x plus 5 over 2. We can multiply both sides by 2, therefore we shall get 20. 2x minus 9 will be equal to 3x plus 5. Open the bracket here, this will be 40x minus 180 will be equal to 3x plus 5. Collect the like terms together. So we have 40x minus, take 3x to the left hand side will be minus 3x will be equal to, in the right hand side we had 5, then plus 180. So this will be that 7x is equal to 185. Therefore, if we divide both sides by that 7, therefore we have 185 divided by that 7, therefore x will be equal to 5, and that is the value of x in this particular logarithmic equation. So we can move on to question 2. The masses of two students in a class were measured as 30.5 kilogram and 36.8 kilogram. Determine the least possible difference in the masses of the two students. So from here we have to remember approximation and errors. So we have been given the actual masses, so we have the actual mass, and in that case we have 30.5 kilogram and 36.8 kilogram. So we need to get the least possible difference. For us to get the least possible difference, first we need to get the absolute error. So absolute error will be given by a half the least unit of measurement. So in our case it is to 1 decimal point. So a half of 0.1, which is 0.05. Therefore, from what we have, we can be able to get the lowest mass, and also we can also be able to get the highest mass. So lowest mass we get 30.5 minus 0.05, so that will be 30.45. And for that 6.8, the lowest mass will be that 6.8 minus 0.05, which will be that 6.75. And then for highest mass, the one measured 30.5, we add the absolute error and we get 30.55. The other one will be, we had 0.05, we get 36.85. So now we have actual mass, lowest mass, and highest mass. So to get minimum or the least difference, so in this case you need just to be very careful. So to get the least difference, so here we have two values. We have the first and you have the second. So for the minimum or least difference, then we need to get the lowest mass or value of that 6.8, then minus the highest value of 30.5. So the lowest value of 36.8, it is 36.75. That's 6.75, and the highest value of 30.5 is 30.55. So if we subtract, we shall end up getting 6.2, and that is the least difference in the masses of the two students. If you try to take the 36.85 minus 30.55, then it won't be the least. Actually it will be less. And the same case, if you take this value and this value, it will still be actually not the least. It will be much higher. So that's how we look for the least difference. So then we can proceed to question number 3. Make x the subject of the formula a is equal to bx all over the square root of x squared minus 9. So the first step we need to do is to square each term. So if we are going to square each term to make our work easier, so if we square each term, so we shall have a squared is equal to bx, we square it all over. Now the denominator part, after squaring each term, we have eliminated the square root sign, so it will be x squared minus 9. Therefore we can multiply both sides by x squared minus 9. Therefore we shall get a squared into bracket x squared minus 9 will be equal to b squared x squared. Open the bracket, we have a squared x squared minus 9a squared will be equal to b squared x squared. Since we are after x, so let me take b squared x squared to the left hand side and 9a squared to the right hand side. So it will be a squared x squared minus b squared x squared will be equal to 9a squared. So now on the left hand side we have x squared. We can factor it since it is common. So if we factor it out, we have a squared minus b squared will be equal to 9a squared. The next step will be dividing both sides by a squared minus b squared. We shall get x squared is equal to 9a squared all over a squared minus b squared. Therefore, now to get x, we find the square root on both sides. So that will be plus or minus square root of 9a squared all over a squared minus b squared. So this will be square root of 9 is 3, square root of a squared is a all over. So the other one will be, so this one will be squared. Remember, this is different between two squares, so square root of a squared minus b squared. So and that is it. In this question, number 4, use a ruler and a pair of compasses. The following figure shows a circle, center O, a tangent to the circle at P, with a tangent to the circle at P is also drawn. So construct another tangent to the circle to intersect the drawn tangent at an angle of 60 degrees. So, just to give an overview of, if this is a circle, and then we have this the tangent passing through that particular point at P, and then this is the center. So, from the properties of tangent, so remember tangent is actually perpendicular to the radius if drawn, so this is 90 degrees. And also, so whatever is being required, we draw another tangent to the circle, but such that this angle will be 60. If this angle will be 60, then we expect this is 90. Therefore, 90 plus 90, that is 180. And whatever now remaining here, so at this point, will be twice this angle, that will be 120. Therefore, we'll be required to construct an angle of 60 degrees and also another angle of 60 degrees, such that it will be 120. Then we join this radius. So from that particular point, we draw the tangent to touch that particular circle. So we can begin. So the first thing I'm going to do is to draw the radius. From P, I join P to O. So I have that is the radius. Then from O, I'm going to construct an angle of 60 degrees. So I construct an angle of 60 degrees. So I'll place the pointer, that particular point. Then I use a radius of different length. So I'm going to put a mark there, and also on the other part. So still maintaining the same radius. So an arc there. Then from there I use this arc on the radius OP as the center, and then I put an arc there. Then from there I join O to the arc, extending all the way to join the tangent. So doing that, so I join from O, passing through the intersection of the tangent that way. Therefore, this angle is 60 degrees. This will be 30, but we require another. If we are going to draw another tangent at this particular point, here should be 60 degrees. The same way I am going to do. So from there, we are going also to construct an angle of 60 degrees from this particular point. So I use this as the center, and then I adjust the compass, put an arc there, and also at this particular point. Then using this as the center, I'll put an arc there. Therefore, I'll join this point so that I have the radius from this point. So that means the radius meets the circumference of the circle at this particular point, and this is the point from where I'm going to join to the point on the other tangent. So now I'm going to join. So that is it, and we have actually constructed tangent to the circle such that the drawn tangent is at an angle of 60 degrees. So that is it. So this angle is 60 degrees. Question 5. A plane took 3 hours to fly from point P, which is 66.42 degrees north, 30 degrees east, to point Q, which is 66.42 degrees north, 52.5 degrees east. Determine the speed of the plane in knots. Correct to 1 decimal place. Correct to 1 decimal place. So, being told that a plane took 3 hours to fly from point P to Q. So if I'm going to draw the sketch of the globe such that you have the equator, so the planes are on the same latitude, line of latitude toward the north, that is 66.42 degrees north, and they're on different longitude. So P is east of Q, so point P is the point P, which is 30 degrees east, and then we have point Q, which is 52.5 degrees east. Now to get the distance PQ, that is along the small circle, so distance PQ, that is along small circle, it is given by 60 times theta times cosine alpha. So we need to get theta and also alpha. So theta is the difference in longitude. Theta is the difference in longitude. So that is 52.5 degrees minus 30 degrees. So theta will be 22.5 degrees. Then alpha is the different in latitude, that is the latitude different, so from the equator or from the center of the earth, so that is the alpha, which is 66.42. Therefore, we are going to substitute into this formula. So PQ will be equal to 60 times theta is 22.5 degrees, then times cosine alpha is 66.42. Using a calculator, we get 540.039335 nautical miles. Remember, this formula is given in nautical miles. Therefore, and the question requires we get the speed of the plane. Therefore, speed is given by the distance PQ divided by the time taken from P to Q. So the distance PQ, which is 540.039335 nautical miles, divided by the time it took is 3 hours, so divide by 3 hours. So we shall end up getting 180.013 nautical miles per hour. But the question requires us to give in knots. So remember, it's a unit for speed, and 1 knot is equal to 1 nautical mile per hour. Therefore, the answer in knot, it's actually divided by 1, so we get 180.0 knots. So that is the speed of the plane. We move on to the next question, number 6. Solve 6 cosine x squared is equal to 5 sine x. 5 sine x for the range of x from 0 to 180 degrees included. Now, this is the equation: 6 cosine x squared is equal to 5 sine x. So we have an x there. Now, from trigonometric identities, cosine x squared plus sine x squared is equal to 1. Therefore, we can rewrite cosine x squared in terms of sine x squared, which will be cosine x squared will be equal to 1 minus sine x squared. Therefore, this equation we substitute into the given equation, and that will be 6. Whenever we have cosine x squared, we substitute with 1 minus sine x squared will be equal to 5 sine x. So open the bracket, we have 6 minus 6 sine x squared will be equal to 5 sine x. So we can rearrange, and if we are going to rearrange it, will be 6 sine x squared plus 5 sine x minus 6 will be equal to 0. Now, since this is a quadratic equation involving trigonometry, therefore we are going to remember it is of the form ax squared plus bx plus c is equal to 0, whereby 6a is 6, and here we are dealing with we have sine x squared represent x squared, and the other case is the same. B is 5, C is minus, but we need to get the value of x. So we can get the product AC will be, we have 6 sine x squared times minus 6, so the product is minus 36 sine x squared. So we need the factors such that when we are going to add them, we shall get plus sine x. So the factors will be, factors of negative 36, we have 9 and minus 4. So we shall have 9 sine x and minus 4 sine x. Remember, if we multiply this 9 sine x and minus 4 sine x, we get minus 36 sine x squared. So that's what we are going to write in the expanded form, the middle part. So this will be 6 sine x squared plus, now write this in the expanded form, 9 sine x minus 4 sine x minus 6 is equal to 0. So we take them into pairs, and we factor out what is common. So we shall have 6 and 9, 3 is common, so 3 sine x, so 3 sine x is common, so we divide 6 sine x squared divided by 3 sine x, we get 2 sine x, then 9 sine x divided by 3 sine x, we get plus 3. Then the other part will be minus 4 and minus 6. So in that case, minus 2 is common. So minus 4 sine x divided by minus 2, get 2 sine x. Then minus 6 divided by minus 2, that is plus 3. Close the bracket, will be equal to 0. Therefore from here we have 3 sine x minus 2 to bracket multiplied by 2 sine x plus 3, close the bracket, will be equal to 0. So either 3 sine x minus 2 is equal to 0, or 2 sine x plus 3 is equal to 0. So you need to get the value of x. So this will be the same as sine x is equal to 2/3, or the other one is sine x is equal to minus 3/2. Now I want you to note that for this one, we cannot be able to get x, since sine of an angle, we cannot be able to get sine inverse of negative 1.5. Therefore this will be the only applicable one. So x will be equal to sine inverse of 2/3, and therefore we shall end up getting x is equal to 41.81 degrees. But have we answered the question? So this is the range, so 0 to 180. So in that case, if you have using the quadratic quadrants, we have the first quadrant, second quadrant, third and fourth. So sine is positive in the first and second quadrant. So in the first quadrant, x is 41.81, and then in the second quadrant it will be 180 minus 41.81, which will be 138.19 degrees. So in the first quadrant and the second quadrant. So these are the values of x: 41.81 or 138.19, in that range. We move on to question number 7. The following table shows the frequency distribution of marks scored by 40 students in a test. So we have the marks and also the frequency, which is shown. So we need to calculate the upper quartile mark. So to get the upper quartile mark, that is 3/4 of the total number of students. So we need to get upper quartile, that is Q3. So the position of the upper quartile will be 3/4 of the number of students, which is 40. Therefore the position is 30th position. 30th position. So in such a case, we also require to get the cumulative frequency. So that will be 4 plus 10, 14, 14 plus 13, 27, 27 plus 8, that is 35, 35 plus 5, 40. So that is the cumulative frequency, and therefore Q3 or upper quartile position lies in the 30th position. So if we look properly into this, 27, that is not inside the 27. So if we check 35, that will be inside 35. So this is our median, the upper quartile position. Therefore, using the formula, lower class boundary of the upper quartile position plus 3/4 nth position minus frequency, cumulative frequency before the upper quartile position, divided by frequency in the upper quartile mark, then times the class interval. So the lower class boundary here will be 40.5, then plus the position is 30th minus cumulative frequency preceding the upper quartile mark is 27, then divided by frequency in the upper quartile is 8, then multiplied by the class interval. If you look clearly, 31 minus 26, that is 5, or that 5 minus 30, that is 5. So class interval is 5. So this will be 40.5 plus 30 minus 27, that is 3/8 times 5, get 1.875. Therefore, if we add together, we get 42.375 marks. So that is the upper quartile mark. We move on. Question number 8. Given that vector P is equal to 5i vector minus j vector plus 3k vector, and q vector is equal to 8i vector plus j vector, and r vector is equal to 2p vector minus q vector, determine the magnitude of r vector. So from here we need to find the magnitude of r. We have been given all these values, and r vector is equal to 2p vector minus q vector, and that's we are actually after the magnitude of r, or in other words we get the length of r. But since we have p vector and q vector, we can substitute. So 2 times p vector is 5i vector minus j vector plus 3k vector. Then minus q vector is 8i vector plus j vector. Open the bracket, this will be 10i vector minus 2j vector plus 6k vector, then minus 8i vector minus j vector. Collect the like terms together. So we shall have 10i vector minus 8i vector, then you have minus 2j vector minus j vector plus 6k vector. So 10i minus 8i, that is 2i vector, then minus 2j minus j, that will be minus 3j vector, then plus 6k vector. Therefore, for us to get r, magnitude of r, remember for us to get the magnitude of value is normally given by x squared plus y squared plus z squared. So in our case, to get r vector will be now the coefficient of I we have, that is 2, so 2 squared plus coefficient of j is minus 3, we square it, and then plus coefficient of k is 6 squared. So this will be equal to square root of 4 plus 9 plus 36. So if we add this, we get square root of 49. Therefore, r, magnitude of r is 7 units. Move on to the next question 9. The following figure shows a circle center O. Determine the equation of the circle and also use the equation in part A to determine the x-intercept of the circle, correct to 3 decimal places. Now, we need to get the equation of the circle, and for us to get the equation of the circle, we need to identify the center of the circle. So the value of x is 1, the value of y coordinate is 1.5, and then we also need the radius. So for our case, the radius is 2 units. Therefore, from general equation, x minus a squared plus y minus b into bracket squared is equal to r squared. So in our case, AB is the center of the circle, and a is 1, b is 1.5. So we can be able to substitute into this equation, and also r is equal to 2. So we can substitute into the general equation, and we shall get x minus 1 into bracket squared plus other one is y minus 1.5 to bracket squared is equals to 2 squared. So you can just simplify this. It will be x squared if we expand this bracket, x squared minus 2x plus 1, then the other part will be plus y squared minus 3y plus, this will be 2.25 will be equal to 4. Can still also rearrange them. X squared plus 2x, that will be minus 2x, then plus y squared minus 3y, so 1 plus 2.25, then we have 1 plus 3.2.25, which is 3.25, then minus 4, so we end up getting minus 0.75 will be equal to 0. Or you can also be able to rewrite it, maybe removing the decimal point, so that is the same as 0.75, the same as minus 3/4, multiply through by 4, which will be 4x squared plus 8x plus 4y squared minus 12y minus 3 is equal to 0. So that's another way you can rewrite the equation of the circle, and it is acceptable. So then part B of the question, you need to use the equation in part A to determine the x-intercept of the circle correct to 3 decimal places. So from the general equation before we actually simplified it, it was x minus 1 into bracket squared plus y minus 1.5 to bracket squared is equals to 2 squared. So we need to determine the x-intercept of the circle, x-intercept where it cuts the x-axis, and it is actually cutting at 2 particular points, at this particular point and also this particular point. So we need to get those values. Therefore, at x-intercept the value of y is 0. When y is equal to 0, we substitute the value of, so this will be x minus 1 squared plus y is actually 0, so this will be 0 minus 1.5 squared is equals to 4. So x minus 1 squared is equals to 4 plus 2.25, so that is actually minus, we shall take it to the other side. Therefore x minus 1 squared is equal to 1.75. Therefore we need to get square root on both sides, and therefore this will be plus or minus 1.75 the square root of. So x minus 1 is equal to, this is plus or minus 1.322. Therefore x will be equal to, so minus 1 plus 1.233, so that is 2.322. The other value will be minus 1 minus 1.2 minus 1 plus, so the other thing we get 0.322. So those are the values, and if you see from the graph, actually they concur. So this will be 0.32 something. It has not reached 0.4. Therefore the other one is 2.3 with some decimal. So that is it for question 9. We move on to question number 10. The following table shows monthly income tax rates of a certain year. So here you have the table, monthly income in Kenya shillings, and also the tax rate percentage in each shillings. So, and in that year, a monthly relief of 2,400 was allowed. The next tax on the single monthly income was 1,500. Calculate Lesianton's monthly income. So we actually don't know the monthly income, and that's where we shall begin from. We say let a monthly income be X shillings. So that is the Lesianton monthly income. So we need to find the value of X. So gross tax for Lesianton will be whatever he has to pay. You can see he has a monthly relief of 2,400. So to get the gross tax will be the net tax plus monthly relief, and the net tax is 1,500. Monthly relief is 2,400. So if we add, we get 3,900 shillings. Then, so this is the gross tax. So let us get the taxable income values. So for the first slab or the first bracket, so what is the income in that value of 24,000? So in the first case it is 10% of 24,000, and this we get 2,400. So for anyone earning 24,000 will have to be taxed 2,400. But still that is not enough. From 3,900 subtracting 2,400, whatever is remaining is 1,500. So that's what now. So in the next bracket, the amount of tax cannot be less, it has to be more. But in our case here now, the next is 1,500. So we need to know the amount from the value of X, that is the total income. So for second slab will be 25% of the remaining, and of the remaining is X minus 24,000. So that's what we get, 1,500. So we need to work out this. So this will be 25 over 100 times X minus 24,000 will be equal to 1,500. Therefore, X minus 24,000 will be equal to 1,500 times 100 divided by 25. So X will be equal to, so this value is 6,000, so it will be 6,000 plus 24,000, so which is 30,000. So X is 30,000. So the monthly income for Lesiantos is 30,000 shillings. Then question number 11. A transformation matrix T 10K0 maps point P, which is 2, 3 onto P prime to 10. Point Q, which is minus 4, 4, is transformed under the same matrix T. Find the coordinates of Q prime, the image of Q. So you have the matrix T. It maps a point P onto P prime. Therefore, that is in the order in which it should be written: the matrix of transformation times the object matrix times the we shall get the image matrix. Therefore, we have the matrix of transformation 1 0 K 0 times now the object matrix, which will be 2 3 in column vector matrix, will be equal to P prime is 2 10. So we need to find the value of K. So in the multiplication of matrices, 1 times 2, that is 2, plus 0 times 3, 0. Then the other one is K times 2, 2K, plus 0 times 3 will be equal to 2, 10. Therefore, we are going to equate this is 2K is equals to 2, 10. So equate the corresponding elements. So 2K is equal to 10, therefore K is equal to 5. The same way we need to find the coordinate of Q prime, which is the image of Q. So using the same matrix of transformation, we transform, we map Q onto Q prime. So the matrix of transformation, now we know the value of K to be 1 0 5 0. Then Q, already we have the point Q given minus 4 4. Therefore we can be able now to get Q prime. So we just multiply 1 times minus 4, that is minus 4, plus 0 times 4 plus 0. Then 5 times minus 4, that is minus 20, plus 0 times 4 plus 0. So this is minus 4 minus 20. Therefore, Q prime, the coordinates, is minus 4 minus 20. Move to question number 12. The length and width of a rectangular floor of a room are 10 meter and 7 meter respectively. A rectangular carpet of area 28 meters squared is placed on the floor. The carpet leaves a uniform space of x meter with each of the walls of the room. Form a quadratic equation in x and hence solve for x. So the first thing I'll have to sketch is a rectangular floor, and dimension is 10 meters by 7 meters. Then there's a rectangular carpet, which is placed on the floor, and I've been given also the area of the rectangular carpet, and then it will leave a uniform space of x meters around the wall. So whatever now we require to form a quadratic equation in x, and then we solve for it. So we need to find the dimensions of the carpet. So since here it will be, here it's also x, so it will be x plus x, that is 2x. So this side is 7 minus 2x, Then the other side of the carpet will be 10 minus 2x. We subtract this length x and this x. So now, and the area is actually 28 meters squared. Therefore, the length, which is 10 minus 2x, we multiply by the width, which is 7 minus 2x, we shall get 28, which is the area of the carpet. Therefore, let us expand at the left hand side. 10 times 7 minus 2x, then minus 2x multiplied by 7 minus 2x will be equal to 28. So this will be 70 minus 20x, then minus 14x plus 4x squared is equal to 28. So we just rearrange. So we have 4x squared minus, so minus 20x minus 14x minus 34x. Then we shall have 70 minus 28, which is minus 42, is equal to 0. We can divide both each term by 2 to simplify it. So we shall get x squared minus 17x, in it is 2x squared minus 17x. Remember, each term we are dividing by 2 to make it simplified. Minus 21 is equal to 0. I can actually use factorization method to solve for x. So I need to get the product AC. Product AC 2 times minus 21, that is minus 42. And then I get factors of minus 42 such that when added I'll get minus 17. So in that case I can have minus 14 and 3. Minus 14 and actually minus minus 3. Remember, this actually a 70 minus 28. This will be plus. This is plus. Also this is plus plus. So minus 14 times minus 3, which is positive 42 when multiplied. When added, we get minus 17 minus 14 minus 3. So we write it in the expanded form, and that will be 2x squared minus 14x minus 3x plus 21 is equal to 0. So take into pairs and factor out. So this will be 2 is common and also x. So this will be x minus 7. The other part we have 3 is common, so can factor out 3, and therefore we have x and minus 21 divided by minus 3 minus 7, close the bracket, will be equal to 0. Therefore this will be 2x minus 3, then multiplied by x minus 7 will be equal to 0. Either 2x minus 3 is equal to 0 or x minus 7 is equal to 0. Therefore x will be equal to 3 over 2, which is 1.5 or 7 centimeter. But we want to see which value is valid as far as this question is concerned. X cannot be 7, otherwise this side is 7. So we cannot have, it will bring a negative value of length, which is impossible. So the only value which is applicable, x is equal to 1.5 meters. It's actually in meters. So that is the value of x. Then move to question number 13. A quantity v varies directly as the square of u and inversely as the cube root of w. When u is equal to 5 and w equal to 8, the value of v is equal to 375. Find the value of v when u is equal to 8 and w is equal to 125. So we need to find the equation connecting the three variables. So then v is directly as the square of u and inversely as the cube root of w. So if we introduce our constant value, so v will be equal to k u squared over cube root of w. So we have been given the value of u is equal to 5, w is equal to 8, and v is equal to 375. We substitute into this equation, so we shall have v is 375 is equal to k times u is 5, so 5 squared all over cube root of 8. So to get k will be equal to 375 times cube root of 8 all over 5 squared. So this will be 375 times cube root of 8 is 2 and then all over 25. So k will be equal to 30. So the general equation connecting the variables is v is equal to 30 u squared over cube root of w. And here we have been given the values of u and w, and therefore we need to get v. So to get v will be w times u. We have been given u is 8, so 8 squared all over w is 125, so cube root of 125. So this will be 30 times 64 all over cube root of 125 is 5. So by 5, 1 by 5, 6. Therefore 6 times 64 we get 384, and that is the value of v. Question 14. A stone was drawn upward from a point 8 meters above the ground. The following graph shows the height h meters of the stone above the ground at time t seconds in the interval t is between 0 and 4 included. So we are required to determine the rate of change of h at t is equal to 2 seconds. At t is equal to 2 seconds. So at this particular point, so what is the rate of change? So we require to draw a tangent passing through that particular point. Then we find the gradient at that particular point. So determine the rate of change of h at t is equal to 2. So we need to draw a line passing through this point, just touching that particular point, and therefore so that is what we have at this particular point. Then we can pick at least 2 points. We can pick 2 points and then we find the gradient. Remember, the gradient we just require 2 points. So that is change in h over change in time t. Therefore, change in h, so we need this point, let me call this point A, is 1.59, and then I have another point B, which is 4. Therefore I need to get a gradient of line AB, so change in y, that will be 4 minus 9 all over 4 minus 1.5. Therefore this will be minus 5 divided by, so 4 minus 1.5, that is 2.5. Therefore if we divide minus 5 divided by 2.5, we get minus 2, and this is meters per second. So that is the rate of change at h is equal to t is equal to 2. Next, question 15. The gradient function of a curve is given by dy dx is equal to 3 minus 4x. If the curve passes through the point minus 1, 10, find the equation of the curve. So we have been given the gradient function, which is dy dx is equal to 3 minus 4x. So if the curve passes through the point minus 1, 10, so we require to get the equation of the curve. So we need to go back, so we do the integration process. So we shall integrate y with respect to x, and therefore this will be dy. So we also integrate y with respect to x. Therefore this, if we integrate dy, that we get y will be equal to, this will be 3x minus, so the other one will be, remember it is 1, so we had 1, then we divide by the new power, we get 2x squared, then plus a constant value. So at this particular point minus 110, so we need to get the value of, so x is minus 1, y is 10, substitute into this equation, general equation, so y is 10, then 3 times minus 1, that is minus 3, plus minus 2 times, so 1 minus 1 squared plus c, so this 10 is equals minus 3, so this minus 2 plus c, this will be 10 is equal to minus 5 plus c, and therefore c is 15. So the general equation y is equal to 3x minus 2x squared plus 15, or you can also be able to rewrite it as y is equals 15 plus 3x minus 2x squared, whichever is acceptable. So that's how you do about it. Then question 16. P, Q and R are points on a level ground. Q is 4.5 meters south of P, R is to the east of P, and 5.3 meters from Q. A vertical post at P is supported by a cable of length 3.5 meters. The cable joins the top of T of the post to point R. Calculate the angle between the cable and the level ground correct to 2 decimal places. So we are required, the first thing to do is to make a sketch for those points, and we are going to begin with P. So P, Q and R are on level ground. Q is 4.5 meters south of P. So if you are to start with the point P, therefore Q is 4.5, that is Q, 4.5 meters south, and then R is to the east of east. R is to the east of P, and it is 5.3 meters from Q. It is 5.3 meters from Q. Then the other thing is a vertical post at P. We draw a vertical post at P is supported by a cable of length 3.5 meters. The cable joins the top T of the post to R. So also at R is another post. So from the top of the post at P, that cable passes through the top to the ground. That way. And then the other information given, the cable joins the top T of the post to R. Calculate the angle between the cable and the level ground, correct to 2 decimal places. Correct to 2 decimal places. So one thing we need to know, that angle between the cable and the level ground. This is the level ground, so this angle is what is required, theta. And if you look clearly, the two posts are parallel to each other, so this angle will also be equal to this angle. If we can be able to get that angle, well and good. So we need also to get this distance, and also we get this distance also. So since this right angle triangle PQR, it's right angle at this point. Since Q is to the south of P, this is 90 degrees. So we can use Pythagoras theorem, and then PR squared plus PQ squared is equals to QR squared. So PR, that's what we are after. PR squared plus PQ squared is 4.5 squared is equal to QR squared, 5.3 squared. Then PR squared is equals to 5.3 squared minus 4.5 squared. So you need to get PR will be the square root of this value. We get 7.84, which will be 2.8 meters. Therefore, that is 2.8 meters. PR 2.8 meters. The same thing, this will be 2.8 meters. Something else that we actually require is to get, we need to get the other information. A vertical post at P is supported by a cable of length. The cable joins the top T of the post to point R. So this is the distance of the cable. So 3.5 meters. So in that case, at that particular point, so we have 3.5 is 2.8. We require this angle theta. So this adjacent and hypotenuse, so cosine theta will be equal to adjacent 2.8 divided by hypotenuse 3.5. So theta will be equal to cosine inverse of this value, which is 0.8. Therefore theta is equal to 36.87 degrees. So that is the angle between the cable and the level ground, and it's to 2 decimal places.